Oh, hey, Ed Johnwalk here. I want to do a introductory explanation on how to do duct design. I see so much stuff on the internet where people are saying this is the way you do duct design. And to be blunt about it, don't listen to them because people are in the habit of making stuff up and we got to stop that. So with that said, I'm going to do my best to keep this at a time frame that's maybe the amount of time for a quality dump. I can't do that. It maybe two. So bear with me as I go through this. I want to emphasize here, I am not trying to teach you how to do duct design. Give me 8 hours, I can do that. Uh, but the things, the musts, the shall to do a quality duct design. How do we do it? Stop making stuff up. Stop making stuff up. Stop setting a duct wheel at an imaginary number. You got to follow rules, and you're going to find really good rules in ACCA's Manual D. ACCA's Manual D will give guidance and tell you to ensure you have enough starting pressure. You're going to make sure that your ducts are large enough. You're going to use dampers. And I got to stop, stick to the script, Ed. And you got to place your thumb over the end of the hose. Yeah, I said that. Breaking those things that I just spoke to down. You got to ensure that you have enough starting pressure. And what enough starting pressure means is you got to have enough oomph. Go in the ASHRAE definitions, and there's a picture of me explaining what oomph is. And that's your fan has enough coming out of it. Without ensuring you have enough starting pressure, you have a system that's not going to function. What does that actually mean? It means you have a duct system that is going to run at an external static pressure higher than your design. It doesn't mean that there won't be any volume coming out the intentional hole in the duct system. It'll mean that there'll be less airflow than is needed for the system to perform as the manufacturer has told us it's going to. Ooh, I like the way that came out. I like it when I don't have to keep redoing this stuff. In this example right here, and it's killing me, but I got to do it. If I have an external static pressure of 0.7 and I have my fan on a medium-high setting, I'm at 1125, right? And I got to stop with the teach, and this is just a high-level overview. You got to ensure you got enough starting pressure. The manual D process. It tells us to figure out which duct in the entire duct system is the critical path. The critical path is the one that's going to have the longest total effective length. The one that we have to ensure that we move the proper volume at an acceptable velocity through the worst one. That is, if you want to call it the magic or the secret of Manual D, there it is. Manual D is a bunch of very low-level mathematical calculations that were taken from some rather high-level engineering calculations. It's very dumbed down. It's simply giving us a path to ensure that our ducts are large enough and we have a way to absolutely ensure that the proper volume goes to where it was intended to go. Again, I like the way that came out. Over here, this is our friction rate worksheet. In the friction rate worksheet, if you follow the 6 steps that are listed in Manual D that you're supposed to do, over here, step 4 is to fill out this worksheet. So literally in Manual D, the first step is to do step 4 on the second worksheet, which I'm never going to stop pointing out because I'm never going to stop finding that funny. Follow the rules, right? You got to ensure that your ducts are big enough. You got to follow the speed limit, right? You got to keep your velocity through your supply trunks under 9, through the return under 7. Yes, it's about noise, but it's about the mathematical calculation that is embedded in Manual D. And take a Manual D class and it gets explained better. Use one of these things to make sure that we're not breaking the speed limit rules. Use one of these with the information from the previous slide where you calculated your friction rate. Stop telling me that your friction rate is 0.08 or 0.0. It is what is produced on that friction rate worksheet. Next, use dampers. The idea behind Manual D is if you follow its guidance, all of your ductwork is going to be large enough not to break the speed limit. And then with the use of dampers, we're going to be able to squish that air to its intended target. There are duct design processes out there that will eliminate the need for the damper. and they are much, much, much more complicated, involved. Essentially, in Manual D, you have to sort of do a calculation that's a dumbed down version, and you do it on one duct, as compared to one of these more sophisticated ones, where if you got 10 drops, you got to do an even more detailed calculation on every drop, right? That's the way it works. And this is my other, I asked ChatGPT to draw me, and I gave it a very detailed description that I wanted a residential duct system that had dampers on every branch run. If you want ChatGPT to fix your grammar and spelling, yes. If you want it to do technical content, that's the crap that it gives you. I am very pro AI and very anti AI. I'm glad that they're never going to be able to send their bots out to troubleshoot equipment, because I don't believe they'll ever understand actually how to do something technical. Place your thumb over the end of the hose. Yes, I said that, and I stick by that. I think I've coined it, and I'm going to continue to use that because I think it's kind of funny. We're talking about determination. Ooh, do you call it a termination? Do you call it a terminal outlet? Ooh, what are we talking about? We're talking about a grill. That's the thing over the intentional hole in the duct system. Now, you might say, well, that's what goes on the return, right? Well, a grill is a covering for a termination that doesn't have a louver in it, right? And we're going to call it a register, and I don't know why I went through that, but I did. These things are super, super, super important, right? They are the thumb over the end of the hose. They're an orifice, if you will. And I talk about ducts can't be too big. Those guys can be too big. We want the air to come out, and we know the volume, right? We have dampers. We are going to ensure that we have the proper CFM, the proper volume coming out of each branch run. That is our goal. And then if we have the proper volume coming out our branch run, we can put our thumb over the end of the hose, and we can get predictable throw and spread. That lady right there is smiling because we got the air coming out. It's not blowing on her head, and it's going to get introduced into the room, and it's going to mix the air, and then it's fat and happy. Thanks to Brian Orr, he sent me these a bunch of these videos recently for me to use, and I'm wearing them out, man. It's you saw the thumb over the end of the hose. My only contribution to this slide right here is putting her in there. I've been using her in my slides for a long time. Oh, and look, it's even animated, and that's what the good throw and spread would look like. But it's on purpose, right? We look it up in a manufacturer's application data. It tells us that a particular register of a particular size at a particular CFM is going to give us a specific pressure drop that we can go back there on that friction rate worksheet and include in our component losses, which, oh, stop, I can't get into the detail on this. But here's another really good video. There is an orifice that the hole's too big. There is an orifice, right, a register that has the proper amount of free area, and we're blowing that air in the direction where we intend it to go. I mean, what more could you ask for? This is probably one of the most overlooked things that I deal with on a regular basis. I had a designer ask me some questions about some stuff in a design, and when I looked at a design that they had produced, there were no registers, and I asked about it, and I am paraphrasing, but the response was, oh, people don't care about that. So what was going to be a 15-minute explanation on the specific task they were asking about turned into 3, because you do it all, right? If you miss a part here and there, it makes a giant difference. Not every time, but it can, so that's the way it goes. I didn't talk about the last worksheet that's in Manual D that we're required to fill out, and that's our duct sizing. That's where our CFM comes from. Don't let anybody tell you your CFM comes from anywhere else. CFM comes from the duct sizing worksheet, and your CFM per room is a product of your heating and cooling factor, which specifically are, oh, stop. Go look at one of my other videos where I specifically talk about those things. That being said, I did it in under 10 minutes because I'm looking at the timer, and I just hit the 10-minute mark, which was pretty good on this topic. I've been doing terrible with how I've been signing off on these. If you have questions about any of this stuff, put it in the chat in the YouTube stuff. There's a bunch of people. I go to the symposium, which I'll be at in January, and I rarely ever do a session. And well, at that event, I get a half a dozen or more Snapchats, and I like it when I look masculine instead of being in a princess dress, but I chuckle no matter what. With that said, take care.